All right, so I want to go over some solving trigonometric equations. You do need to have these common trig identities memorized, especially sine squared plus cosine squared equals 1 and the reciprocal identities. The double angle identities are not used quite as often, but they are good to have memorized so that you can use them to simplify integrals and derivatives when we get there. We have not gotten there, but it can be helpful in later chapters. That's why they're introducing it now. Okay, so we are going to start with A, which is tangent of x times cosecant x equals 2. So first thing I'm going to do is see if I can simplify these at all. So tangent is sine over cosine, and cosecant is 1 over sine. Your sines do cancel, so you get 1 over cosine x equals 2. I want to get my cosine x on top, so I'm going to multiply both sides by cosine x. And I get 1/2 equals cosine x. I divided by 2. I should have written that down. Oh well. So 1/2 equals cosine x. And I do want to point out, although it will not come up in this particular problem, but although we canceled the sine x's, you just have to keep in mind that sine x cannot equal 0, because otherwise the beginning of the problem, your original problem, would be undefined. So just make sure that when you're getting answers, that answer does not also correspond with a sine value of 0. That won't happen here because you know if your cosine value is 1/2, that means that your sine value will be either root 3 over 2 or negative root 3 over 2. So that's not going to be a problem. But it is something that you want to keep in mind. We are solving over the interval 0 to 2 pi. So I am going to do a quick sketch so that I can remember where's my cosine equal to 1/2. 1/2 is a little bit, and I'm going over that much. So I'm going over a little bit, up a lot, and then over a little bit, down a lot. That's where I have positive cosine values because cosine is the x coordinate on the unit circle. So that is going to be pi over 3. And then all the way around, that would be 5 pi over 3. And again, the way that I remember how to do this is I use ideas like a little bit, a lot bit. Because this is a large angle, that's going to be a third, not a sixth. And then this is negative, the same amount, negative pi over 3, but that's not actually in between 0 and 2 pi. So I add 2 pi to negative pi over 3, and that's how I get 5 pi over 3. Or you can just count thirds, 1/3, 2/3, 3/3, 4/3, and 5/3. All right, B, sine of x times cosine x equals 1/4. There's two things you can do here. You can try to guess and check almost, and see if you can get sine values times cosine values that equal 1/4. I would not necessarily recommend that way, but it is certainly possible. What I would do is if I'm getting something that I can't easily solve, what I want to think of is there some sort of identity I can use to simplify this? There is. This looks really close to 2 sine cosine. So what I'm going to do is I'm going to multiply both sides by 2 so that it is 2 sine cosine. And then that gives me the double angle identity sine of 2x. So this would be sine of 2x is equal to 1/4 times 2, which is 1/2. So now I'm going to think about this as sine of something is equal to 1/2, because I do know places on the unit circle where the sine values are equal to 1/2. So what I'm going to do is I'm going to use substitution. You don't really have to show this step, but I find it's easier for students if you do show this. So sine of y is equal to 1/2. I solve for y, and then I can go back and actually solve for my x values, since that's what I wanted to solve for in the first place. So where on the unit circle do I have sine values of 1/2? That would be at going up a little bit on both sides. So that's pi over 6, 5 pi over 6. And I figured out it was 5 pi over 6 because that's a little bit less than 1 pi. 5/6 is a little bit less than 6/6. Okay, so that would be what your y values are equal to, but that doesn't actually solve your x values. Your x values are going to be half of that amount, because y is equal to 2x. So you can either actually write down y at pi over 6 is equal to 2x and solve, but you're basically just dividing by 2 anyway. So you get pi over 12 and 5 pi over 12. The important thing to remember here is because you're using a double angle identity, you probably also have double the answers. So there is a little bit of extra thinking here. The normal period of sine or cosine is 2 pi, which means that the values repeat every 2 pi. When you're using a double angle identities, because we divided by 2, the period of these guys is going to be pi, 2 pi, which is the normal period, and I'm dividing by 2 to get the new period. So the reason I need to take that extra step into account is because these two are not my only answers. It also would happen at pi over 12 plus pi, or 12 pi over 12, which is 13 pi over 12. So that's another answer. And then another answer would be 5 pi over 12 plus 12 pi over 12, which would be 17 pi over 12. So the idea here is that because you are dividing by 2 to get your answers for x, you also need to divide the period by 2, which means your answers are going to repeat every half circle instead of every full revolution. And you might want to keep going just to double check, like if I add pi again, then that is also an answer, but it's just not an answer between 0 and 2 pi, so I can stop. So this gives me all 4 answers that are between 0 and 2 pi. So yeah, when you are using the double angle identity, keep that in mind. Okay, so number C, part C, I'm writing all over my screen here. This is not as neat as I would expect your homework, so I apologize about that. 2 sine squared minus cosine minus 1. I should really be more consistent about my parentheses, but whatever. Okay, so I see sines and I see cosines. Now this one, every time I see a sine squared or a cosine squared, I automatically just kind of think Pythagorean identity. Sine squared plus cosine squared equals 1, because that is the identity that's used the most often in out of all of these, I would say, besides the reciprocal identities. So I use this identity a lot more often than I use double angle or half angle identities. So what I'm going to think is, can I get all of these to be sines or cosines? If I can replace sine squared with cosine squared, or something to do with cosine squared, then it would all be cosines, right? And I can't replace cosine with anything that has sine. There's nothing that'll help me there, so I have to go with the sine squared. Well, if I know that sine squared plus cosine squared is equal to 1, sorry about my phone, I should turn it off, then what I can do is subtract cosine squared, and I get sine squared is equal to 1 minus cosine squared. So now I can use substitution, so that's 2 times 1 minus cosine squared minus cosine minus 1 is equal to 0. So that's 2 minus 2 cosine squared minus cosine x minus 1 equals 0, which is negative 2 cosine squared minus cosine plus 1 equals 0. You can leave your quadratic, which you should realize this is a quadratic. It's almost as if it were negative 2x squared minus x plus 1. But instead of x's, they're cosine x's. Still, you're going to treat it the same way. If you're going to solve a quadratic like this, you can always divide by negative 1, which I am going to do right now, just so that I don't have a negative. And I don't know why I don't enjoy having a negative in front, but I don't enjoy it, so I'm going to change it to a positive. 2 cosine squared of x plus cosine x minus 1 equals 0. It's not going to change your final answer. It's just a personal preference. I'm going to put a times c on top and b on the bottom. This is just the way that I personally like to factor. You can factor whatever way you want. So what multiplies to be negative 2 and adds to be 1? That would be negative 1 and positive 2, because they have to multiply to be a times c and add to be b. And all these two numbers are, is it's splitting up the middle piece into those two pieces. So I have 2 cosine squared, that doesn't change, minus cosine, plus 2 cosine. Again, it's just, if you look at your middle piece, you're splitting it into these two pieces. Minus 1 equals 0, and then I can factor by grouping. So that's cosine x times 2 cosine x minus 1, plus 1 times 2 cosine x minus 1, since there's nothing else I can factor out but a 1. Then I am going to factor out a 2 cosine x minus 1, since two pieces both have 2 cosine x minus 1, times, and I'm left with cosine x plus 1 0. Then you can set each part equal to 0. This is called the zero product property because it is a product of two things that equal 0. And I do want to point that out because a lot of people try to do this and they factor and it's not set equal to 0. It has to be equal to 0 before you can do all this stuff. So I'm going to add 1, divide by 2, so I get cosine x equals 1/2 over here. Subtract 1, and I get cosine x equals -1. So where on the unit circle is my cosine value equal to 1/2? That would be over a little bit. So that's going to be pi over 3 and 5 pi over 3. And then cosine x equals -1, so that's backwards 1. So that is at pi. So here are my answers. There you go. I was just trying to leave it up so that if you were still copying, you can do that. Okay, so there are my answers. Then part D, tangent plus cotangent equals -2. -2. Okay, so I'm going to see if I can put this in terms of sine and cosine because that's a little bit easier for me. So it's sine over cosine plus cosine over sine is equal to -2. I have a fraction plus a fraction, and I don't really see anything I can simplify right now, so I'm going to go ahead and get a common denominator and see if that helps me. And I have not solved this problem yet, so I mean, this is me literally doing my thought process, trying to figure out how to do this, and I'm just kind of guessing on some strategies here. So I'm going to multiply this one by sine over sine, and I'm going to multiply this by cosine over cosine. So then I have sine squared plus cosine squared on top, and then my denominator is sine cosine. Equals -2. And oh my god, I see sine squared plus cosine squared, so that equals 1, because that is the one I had memorized. Equals -2. Now, there's a few things I can do. I don't really like having sine and cosine in my denominator. I'd rather have sine cosine equal to, I'd rather have sine cosine on, like, as equal to a fraction. So I'm going to multiply by sine cosine. Sine x, don't just write sine, that doesn't make any sense. Do that on both sides, cancels. I get 1 equals -2 sine cosine. That rings a bell, haha, because my phone just went off. But also double angle identity, 2 sine cosine is equal to sine of 2x. So if I divide this by -1, I have 2 sine cosine, which is equal to sine of 2x, using that double angle identity. Again, I'm going to kind of use substitution here. Y equals 2x. So -1 equals sine of y. So where do I have a sine value of -1? That happens at 3 pi over 2. And that is equal to 2x. So x is equal to 3 pi over 4. And because the period of sine and cosine is normally 2 pi, I need to divide that by 2 because I had to use a double angle identity. So this will also happen every pi, every half revolution. So I'm going to go ahead and also add, so let's do 3 pi over 4 plus 4 pi over 4 to add a pi, and that's 7 pi over 4, which is also in between 0 and 2 pi. So that is also in my interval. So both of those are answers. And just keep that in mind that when you use a double angle identity, it also divides the period of the function in half. So if you were solving a tangent double angle identity, which didn't come up, but let's say it was a tangent double angle identity where you had tangent of 2x, the period of tangent is actually pi. So if you're using a double angle identity, your period would be pi over 2. So that's trig identities. There is I don't want to give away too much, but you should be able to do this before you take your test on Monday. So just maybe keep that in mind that you should know how to do these problems. So yeah.